that big enough for you to see?
Yeah, perfect.
I can expand it if I need to. All right, so this is a quadratic. So we know it's a, what kind of shape is it?
Parabola.
Okay. Is this going to be a parabola that looks like this or a parabola that looks like that?
Got it.
It's the one on the left. It's this one. It's going to open up. And the reason I know it's going to open up is because I look at the coefficient of the x squared term and it's positive. It's positive 1. That's
Okay.
that's what matters. If it was a negative anything, then it would be an upside down parabola. All right, now, first of all, they want its vertex, they want its x-intercepts, they want its y-intercepts. Also factor the quadratic. Well, notice that there's lots of ways to get each of these. The vertex, I could use minus b over 2a. But since they've said factor it, well, let's factor it. What does it become?
It becomes so on the left it's going to be a x, and on the right there's going to be a x. It's going to, I assume it's going to be a minus sign and a positive sign in one of the,
Hold on.
like,
Just assume you were correct. When I multiply those two numbers together, am I going to get a minus or a plus?
minus.
What do you see there?
Positive. Oh, oh,
So
so
it
they both have to
cannot
be
be
positive.
opposite signs. The signs have to be the same by that measurement alone. Now, are they minus minus or plus plus?
Minus, minus.
Correct, because the sign on the middle term is minus. Now, this is a simple quadratic, so I can use those rules that I taught you. What am I looking for? Factors of what that do what?
Factors of 7 that equal -8.
Not that equal. You keep always saying
Add 2.
add because sometimes it's subtract, not always add. But it's add
Yeah.
or subtract. It's not equal to. So factors of 7 that add to the number 8, well, that's nice. That's those two factors.
Hmm.
Now, that does tell me something that will avoid me having to use minus b over 2a. First of all, what are my x-intercepts? I can answer this one right now based on factoring.
Oh, yeah. Your x-intercepts are +7 and +1.
Good. So I know that parabola goes through there. Now that actually tells me what my line of symmetry is also. What does that line of symmetry have to be? X equal what? What's halfway
X
between 7 and 1?
halfway between 7 and 1 is 4, 5.
What you do is you add the two numbers together and you divide by 2. That's how you figure out halfway. Okay?
Mm-hmm.
So that tells me the x coordinate of the vertex is 4. Gosh, I've figured out a lot now. Tell me what the y coordinate of the vertex is.
The mm,
How am I
I
going
don't,
to get that?
by doing a over b
No,
minus a over b.
don't need to do that. So all I need to do is know what y is equal to when x equals 4. Remember, the vertex is a single point. So if I tell you that the x coordinate of the vertex is 4, And you can plug it in, and you get 16 minus 32 plus 7, which is minus 9. Now, I have everything except the easiest part, which I'll get to in a moment. But notice I know where my vertex is. My vertex is right there. That is 4, comma, minus 9. Okay? I even know how the thing draws. It's got to go through the vertex, and it's got to go through both those x-intercepts. So it looks something like that. Now, the only thing we haven't answered is the y-intercept, and that actually was the easiest thing to answer from the get-go. How do you get the y-intercept when you have it in standard format? Remember the rule. The y-intercept is when x is 0. So plug in 0 for x and tell me what you get.
0 for x where?
Right here, into our primary equation. Plug in 0 for x. Solve for y.
Do we have to, I'm confused what to do. That's the thing.
Well, when you plug in 0 for x, that goes away. When you plug in 0 for x, that goes away. The only thing you're left with is the number.
Oh, okay.
And that is right there. So the y-intercept is 0, comma 7. And the reason I said that's the easiest thing is because it's always, whenever you're given the quadratic in standard format, which is what that is, it's not in factored format, it's not in vertex format, it's in standard format. One of the things I want you to remember is that x-intercepts means y equals 0, y-intercepts means x equals 0. So if I'm trying to figure out the y-intercept, I plug in 0 for x, and that always gets rid of that and that term every time. The only term that's left is the number. So that's always the y-intercept, is that number.
Yeah.
So we did exactly what they wanted. We got all three things. We got the vertex, 4, comma, minus 9. We got the x-intercepts, which were 7 and 1. We got the y-intercepts, which is 7. And we factored the quadratic. And we graphed it.
Yay.
With all the points. In other words, we did every single thing they were looking for. All right, let's go to the next one. I'm going to have to scroll. Oops. Scroll down a little bit. I am going to expand this a little bit. No, I guess I'm not. Yeah, I guess I can expand it this way. Yeah, that's a little bit better. Okay, so what we have here are 3 different graphs. 3 different tables mean 3 different graphs. Okay? Now, remember what I just told you. X-intercepts come when y is 0. Y-intercepts come when x is 0. That makes this extremely easy. I want you to tell me where the x-intercept is on this one right there.
The x-intercept is 2.
Well, it's 2. It's also minus 4, and it's also 3. In other words, what if I had a graph that was kind of like this? You got multiple x-intercepts, right? There's one there, there's one there, there's one there, there's one there. So you can have more than one x-intercept. What you cannot have is more than one y-intercept. Because if you had more than one y-intercept, it wouldn't be a function. It wouldn't pass the vertical line test. So the x-intercepts, that one, and that one. Where's the y-intercept on that first table?
18.
Very good. That's where x equals 0. Okay, how about the next one? Give me the x-intercepts.
The x-intercepts are 3 and 8.
And the y-intercepts.
The y-intercepts is just -3.
Yeah, it's that simple. I love this question because what this question reinforces is x-intercepts are when y is 0, y-intercepts are when x is 0. How about the third one? X-intercepts.
The x-intercepts are just, there's 1, 1.
And y-intercepts.
-4.
Right. And like I said, there's always only going to be one y-intercept. Notice that if you had two y-intercepts, couldn't be a function. That doesn't pass the vertical line test. You can draw a vertical line through that and it fails it. So when you're talking about functions, there's always only one y value for a given x value. Okay. We're given a system of equations. Very, very common question. Now, the question you always have to ask yourself, you know, two methods for solving these, correct?
Yes, substitution and elimination.
Okay. On A, which are we going to use?
Substitution.
A is in standard format. The entire left side and the entire right side is in standard format. That's an elimination. That's begging to be solved by elimination. In B, this one is solved completely for y. That's begging for substitution. Okay? All right, so let's do the first one. I'm going to call that equation 1, call that equation 2. We're going to eliminate, but at the moment, nothing eliminates. So what can I do?
You could multiply equation 2 by 2.
Okay, so now I've got 6x minus 2y equals 4. That's my new equation 2. Now, how can we eliminate stuff?
We could eliminate two things. We could eliminate the x's and the y's.
By doing what?
By subtracting.
Okay. Always be wary when you can eliminate two things, because we're only trying to eliminate one variable. If we eliminate both variables, we're going to get 0. I've got to subtract the two numbers. So when I get one number equals a different number, that's impossible. What does that tell me about the solution?
It's
no solution.
Oh.
Remember, there's three possibilities on these things. You can have no solution, you can have a specific solution, or you can have an infinite number of solutions. But whenever I solve it, by whatever method I choose, it doesn't matter whether I had used elimination or substitution, I still would have gotten one number equals a different number. Well, that is an impossibility. When you have an impossibility, that means no solution. Okay? Now, let's go up and solve number B.
Got it.
We've decided we're going to use substitution because, first of all, they're not in standard format. These two are in standard format. Very easy to use elimination on. This one, not so much. But on the other hand, y is completely solved. So what's the next thing I should write?
Figure out what. Oh, Wouldn't we just have to write?
Substitution. That's what we're going to do.
Got it. I forgot how to do substitution. We've done a lot of elimination.
Okay.
I just haven't seen.
You're right. We have. So let's go to the other equation. X minus 3. But instead of saying y, I'm going to substitute what y is equal to. Well, y is equal to 16 minus 2x, right?
Yeah.
Okay. And then that's all equal to 1. Well, notice what I've done. I've turned it into one equation only and one variable. You can always solve those. Always.
Yep.
What are suspect is when you have two equations and two variables. Usually you can solve those, but not always. But when you have one equation and one variable, in this particular case, I'm going to leave my variables on the left side because that's where they are. I don't want them, oh, and it also that gives them a positive coefficient. See how I got to that step?
No, I do not see how you got there.
Okay, well, going from here to here. So all I did was distribute the 3. Excuse me. So all I did was distribute the minus 3. Well, minus 3 times 16 is minus 48. Minus 3 times minus 2x is plus 6x.
Got it.
So that's how I got from that step to that step. Now you just gather like terms. I got an x plus a 6x, that's 7x. Got a positive coefficient, definitely leaving it on the left side, which means I got to take this negative 48, move it to the right side by adding 48 to both sides. Now I get a solution for one of the variables. I still, in order to solve a system of equations, you always have to solve for both variables. So I know x equals 7. Now what? How do I get y?
Do we do the?
Again, use substitution.
All right.
Which equation is going to let us solve for y?
Equation 2.
Okay. So y equals 16 minus 2 times what we just solved for x, 7. So y equals 2. So our solution is x equals 7 and y equals 2.
2.
And if we're looking at this graphically, it would basically mean we have two lines that cross. And wherever they cross is the solution. That is the first equation's a linear equation, the second equation's a linear equation. As long as they are not parallel, they're going to cross at some point in time. And wherever they cross is your solution. If we had a graph of these two lines, all I would have to do is look for where they cross, and that is the solution. It would be at 7, 2. Now, let's talk about that for a moment. Because the first one we came up with was no solution, right?
Yeah.
Well, what no solution means is you have two parallel lines. So two parallel lines, in other words, that one's one parallel line, and that one's another parallel line. And parallel lines never cross. Doesn't matter if you go all the way to infinity. That's the definition of parallels. They will never cross. So there will never be a solution. Solutions require these lines to cross. So that's what's going on in this picture here is you have two parallel lines. That's why we got 0 equals 4 or 6 or whatever it was. We had one number equal another number. That means no solution. Here we got a specific x and a specific y. That means at 7, 2, those two lines cross. All right. Numbers 4.
Got it.
4a.
All right. So it's kind of like, I'm not sure. Like, we've gone through these signs in class, I'm sure of it, because she gave it to us as homework, but it's just like,
I don't care if you've gone through this or not. Look at that symbol. Now look at that symbol. What's the difference between them?
One's facing another way.
One means less than or equal to. What do you suppose this one means?
Greater than equals to.
Greater than or equal to.
Greater than or equal to. Got it.
If this one means less than, then what does this one mean?
Greater than.
You got it. It's that simple. B, how can you write an expression that states 5 is greater than 3? 5. Tell me right arrow, left arrow, right arrow with an equal sign, or left arrow with an equal sign?
It's the right arrow without the equal.
Without the equal sign. 5 is not greater. Well, I suppose technically 5 is greater than or equal to 3, but it's definitely greater than 3. Okay. And that's what the words say. In other words, the fact that it said greater than, we're only using that sign right there. Okay. How about C? Write an expression that says x is less than or equal to 9.
Oh. It will be the left arrow equal sign.
Okay. Translate that into words.
And it will say 2 is less negative 2.
That's not a 2.
Huh?
That's not 2.
Negative 2.
Okay, there's a huge difference. Those two numbers are 4 units apart.
Yeah.
Negative 2, what's the rest of it?
Is less than 7.
Perfect. Oh, good. Factoring. As I've always said, one can never get too much practice factoring.
Yes.
Now we've got one easy one. And why are these hard?
Because they have a number on the x.
They have a coefficient on the x squared that is not 1. In other words, this one has a coefficient of 3, this one has a coefficient of 2, this one has a coefficient of 3. That means it becomes kind of a trial and error process when you're factoring them. You can't use the rules that I taught you, but you can on this first one. Let's do that one.
I've solved it already.
Okay.
So it is x's are in both sides, on both ones, and then there is a positive on the left and a negative on the right. And the numbers are 5 on the left and 3 on the right?
Very good.
And then
Second one. Little
second one,
harder because you can see the x's are going to have different coefficients after you split them apart. So one is 3x, the other is x. They have different coefficients now. Changes everything. Okay, what's the second step on the second one?
figure out what factors of 2
Nope,
subtract to
nope,
5.
nope, 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 nope. Remember, you
Oh,
cannot
sign.
use any of those rules when that is other than a 1. Throw those rules out the window. They're not going to apply. Besides that, that's not the second step anyway. What's the second step?
To figure out the signs.
Both signs. That's always the second step. What do both signs have to be?
Negative.
Now, see, now we're so much closer to the end because I've only got 2 factors of 2. That's 2 and 1. So it's either 2 on the left and 1 on the right, or 1 on the left and 2 on the right. So let's try this one. And again, at this point, you can kind of look at it as trial and error. You know, there's only 2 possibilities. Does this one work?
Yes, it does.
It does, actually. I actually thought I was giving you the one that didn't work. But this one does work. That totals minus 5x. Whereas, had I had the 1 there and the 2 there, then that's minus 1x, that's minus 6x, that would give you minus 7x in the middle, and that's not what we got. So, very good. Okay, let's keep going. We want to get some practice with these harder ones. These are hard, but they're not that hard. In other words, they're still trial and error. The only reason I call them second degree is because you can't use the same rules. It really requires a whole different way of doing it. But the first 2 steps are always the same. First
All right.
step.
To split the 2x squared, put 2x on the left and x on the right.
Second step.
Second step is to determine the signs.
Which are?
And from them both being negative, I would assume that it would...
If they were both negative, that would not be a negative 35.
No, I was meaning since 9 and 35 are negative, that it would have to be opposite signs.
They have to be opposite because of that only, nothing else. Does not have anything to do with this negative sign over there. They have to be opposite because you cannot produce a minus 35. Remember, that's the last term of FOIL. That's where you multiply the 2 numbers together. So it's got to be plus minus, but it could also be minus plus. You realize why they're not the same in this case, whereas they're always the same if that coefficient is the same.
Mm-hmm.
Okay. Now, we just have to examine factors of 35. What's another set of factors of 35? Let's talk about how you find factors. Can I divide 35 by 2?
No.
Can I divide it by 3?
No.
I don't even need to check 4, because if I couldn't divide it by 2, I definitely can't divide it by 4. Can I divide it by 5?
Yes.
So if I cut that in fifths, it becomes a 7, which means I have to multiply this by 5. So there's 2 other factors. Now both of these are prime numbers, so I definitely cannot break it down anymore. So I got 2 choices here. I can deal with 35 and 1, or I can deal with 7 and 5. Which one am I going to start with in my trial and error process?
7 and 5.
Always the 2 that are closer together, just because that is much more likely to be the correct answer. Okay? So we'll just start right here, 7 and 5. I won't give it any more attention. I'm just going to trial and error. What does that produce as a middle term? That's going to tell me a lot. as to what that produces as a middle term. Let's see, that's plus 7x. That's minus 10x. That's minus 3x. I'm looking at a middle term of 9. So that tells me something. It tells me this is not correct. And it also tells me that if I drop the 7 down to the negative sign and the 5 down to the positive sign, this would merely turn into plus 3x. So that's not correct either. So
What if you
my
switch?
7 can't go on the left. My 7's got to go on the right. So let's put the 7 on the right and the 5 on the left. Just randomly, 5 and 7. Now let's look at a middle term, plus 5x. In other words, this double smiley face is an integral part in coming up with the solution. If you couldn't do this, you wouldn't be able to figure out what that middle term was. Bingo, we hit it. Minus 9x. There's your solution. I erase that negative, that positive, all of that stuff there, and I know that if I multiply those two things together, I get that quadratic. Okay?
Okay.
So you can see the process is a little different, but starts out exactly the same. You split up the x's and you determine both signs. Okay? So let's look at that one there. That's a little different looking than any of the others. Let's see if we can rewrite it for starters. How am I going to rewrite it in proper polynomial format?
By putting everything, I don't know. It would just make it, what I was thinking would make it
That's the first term. That's the second term. That's the third term. So in proper format, I'm going to put the x squared term first. I'm going to put the x term next. And then I'm going to put the number. And as all I did was I swapped sides. I put everything on the left that was on the left on the right, and I put the y that was on the right on the left.
Got it.
Okay. Now let's see if this factors. Factor that for me. One step at a time.
Got it. So we put 3x on the left, and we put x on the right. And then we determine the signs. And by seeing the middle term, it's going to be positive, both positive.
Very good.
And then we have, this is confusing also, but it's kind of like.
It couldn't be. There's only two factors for the number 2. That's always the next step, is to figure out what the factors are on that constant. That is the constant term. It only has one set of factors, 2 and 1. So either it's 2 there and 1 on the right, or it's 1 on the left and 2 on the right. Can you figure out which one's going to create this middle term in your head? I mean, we can do it by trial and error, but at some point you're going to get to a point where you can figure out which side the 2 has to be on and which side the 1 has to be on.
2 on the left, 1 on the right.
Well, let's see. Does that produce the right middle term? You tell me.
So positive 2x and then 3. No, it doesn't.
Okay. Then there's only one other choice in this case. And that
makes sense.
Put the 1 on the left and the 2 on the right. Does that produce the proper middle term?
Yes, it does.
There you go. That's how you do those. Okay. And I'll put that method up against anybody's method, the California method or the Diamond method or any of those that they taught you. And the thing is they're not going to give you anything much harder than this. Notice they only gave you one easy one. That was that one. These three here, you could not use that definition of factors of 15 that subtract to the number 2. Couldn't use it on any of the others. And you never will be able to. If the only time you can ever use that is if that coefficient on the x squared is 1. Has to be precisely 1. All right. We're done with this page.
Yeah. This is all I needed help with today.
Okay. It's fine. We can call it a day.
All right. Thank you, David.
I feel like you're definitely picking this stuff up. I do. I can tell you're getting more confident and you're knowing how to do stuff now that you couldn't do even a couple sessions ago.
Actually, real quick, I'm going to go, before I go, I wanted to check if my test results came in from the test I did on Friday last week, I think.
Okay.
I just want to see if they're in. If they're in,
yeah, if you want to go ahead and look at that while we're still online, and if you see any that you want to go over, go ahead, take a look.
Oh, I can't get the test online, but I just wanted to, okay, chapter, no, that's not it. Nope, it's not on. Damn it.
Okay, we don't have another session scheduled for this week or next week. So
I'll talk to my dad about that.
Okay.
All right. Thank you.
Sounds good. I will talk to you next time, Josh.
All right. See you.
All right. Bye-bye.
Bye.